All right. Hi guys. Today I'm gonna show how to choose some parts in on Digikey. It's quite important to know what parts you need and how to choose them instead of just typing like 2.54 mil header instead of typing this. Very important to uh, understand understand how Digikey organize the parts, right? So, for example, let me start from the simple one, the connector that I was just showing. It's a very simple 2.54 pitch male header connector or even female. So, yeah, this is the one that I was talking about. So, generally, what we want a schematic of the software that you're using. I'm using Allegro, so I need an ORCAD or Allegro schematic symbol. Then what else? The footprint, the path file, the step file, and the 3D files, right? So how Digikey organize this particular header 2.54, and I'm going to go for other complicated header as well, and power supply connector. So those are the examples that I'm going to go through. For now, okay, let's start with this simple header right here. So what I'm going to do is if you see here, let me just go back. Okay, so let me just I just search for 2.54 mil header. These are the things that comes up. But let's say I want specifically like 20 cross 2 header. How am I going to search? I don't have the part number. I don't have exactly, you know. So this is just three by one. How am I going to search that? So if you see one um, point over here, like there's a connector, interconnect, regular connector, and header mail. So I'm just trying to explain how Digikey organized your products. So if you see here, these are the clues right here in front of you. So connector, rectangular connector, header mail. So I'm going to go to connector, rectangular connector, header mail pins, and here it is. So what I'm going to do is we're going to need two rows and how many pins we're talking about. We're talking about 40, 20 cross 2, right? So 40 pins. So number of position is 40, and I can immediately apply these two conditions, number of position and number of row, and they are showing up right here. All right, and what else? And I can uh, filter it out by pitch as well, 2.54 mm, that is zero point 0.1 inch. I can apply in the filter. So I already have three filter, and header mail 2.54, number of position, and row spacing. Yep. So this is what I'm looking for. Yeah, and before that, I can even yeah. So this is the exact header. One more filter that you can put through is the ECAT model, and important, very most important, stocks as well. Yeah, you can apply again. Yeah, even if you have a part, if it is out of stock, what is the use, right? Um, yeah, but nonetheless, you can always pick up the 3D model or footprint and symbols. So this is the header. So and this is what we're gonna need for the design, symbol, footprint, and the 3D model. That's all. And similarly, if we go for the female, we can go to. So let me quickly save this product right here. This is the male connector for Raspberry Pi. I have some videos which I've already uploaded earlier. So for female, what we're going to do is we're going to go to connector, then we're going to do the same thing, rectangular. Then what the yeah, female socket. Okay, then we can do the same thing, like number of position, number of row is 2, uh, then 2.54 bits, and 40, and EDA with EDA, and you can even put uh, what is that, uh, mount type, I guess. Yeah, mount type, uh, as a true hole. So we want true hole, right? If you want SMD, you can choose SMD. Um, yeah, mount type right here, true hole or surface mount. Mm. Yeah, I can even try for SMD. No, it's better to for true hole. Yeah. So and then I'm gonna select in stocks and apply all. Yep. So let's check what do we have here. Yeah, 3D model. All right. So this is what we have. Let me quickly check the one that I'm using right now. PPC 202. PPC 202. I just want to make sure I can use any one of them. PPC 202. Okay. So this is the one that I'm using. I can even look into the cost, and choose the least cost, you know. So this is the least cost. Uh, yeah, and one more thing that which might be important for designers is the coating finish, contact finish gold. Yeah, so this might be important as well. Uh, I'm pretty surprised that gold coated is cheaper as compared to tin. Yeah, anyway. So yeah, so this is the second part that we looked for, and the third one is we're gonna look for this connector, power supply DC for 12 volt, 5 volt for the board, female and male. So okay, for that, what I'm going to do is product again, uh, connector, then what is that? Um, um, terminal block. What is it? Terminal block. Um, rectangular connector. Um, then yeah, one should be in the male, and one should be in the housing. Okay, so I've just selected two of them. So here, what we are looking at first is this particular connector right here. Um, yeah, just hold on for a while. All right, so this is the connector that I'm looking at. So it's a male connector, as you can see. There's a pin right here, and this will be its corresponding female connector. And we really need three parts. One is this, and one is this housing, and the third one will be this part right here, which is the cream, which will be the female the wire with the crimp will be going inside this hole, and then they become complete connector. So this is what we are looking at first. Yeah. So mm, where were we? Yeah, we were opening this. Yeah, so we are in the header mill pins, and one thing that I would like to point out is this is if you see, let me measure them quickly. Um, Pins. All right, so this to this it should be 3 millimeter apart. Yeah, as you can see, dy is 3. Yeah, so that is one important thing. So, and we want true hole for sure. Right, so we want true hole because we want bottom connector, but bottom layer to have the supply or even the inner. So we want a true hole identity. So those are the constraints, and I can start applying those. So first of all, simple one, the number of position, number of row is 1, and we want 2, right? And then pitch is how much? 3 millimeter. And what else? And we want a true hole. Where is that? Where is that? Where is that? Packaging, contact type, connector type, header, row number, style, and type, termination first. Um, Gold. Okay. Why am I not able to find this? Connected type, true mounting type. Okay, alright. Control F. Mounting type. Yeah, here it is. So I can, for future, when I design my own board, I'm going to choose. I'm extremely sorry for the noise. So I'm going to choose true hole. Yeah, so in the future board that I'm going to design, I'm going to use assembly, but for now, true hole. Yeah, ECAD in stock, apply, and let's say in case if the expected part is not showing up right here, what I can do is I can quickly increase to 100. You know, yeah, the number of items. So, and one thing is we want uh, 90-degree connector, right? We don't want straight. We want 90-degree connector. So this looks straight. It should be mounted from the top of the board. Yeah. So is it mentioned here? There should be square, tin, brass, blah blah. Um, most of them looks straight. Yep. So this is again. This is straight as well. Hmm. Mill, true, log, square. There should be part with. Is it this one? I don't think so. Okay. I'm going to do is let me remove this mounting type for time being. And yeah, I think this is the one. Yeah, so as you can see, the connector is at the bottom, right? Main pin is at the bottom. That's what we want. Yeah, not, 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 not this. Like, for example, this one. If you see here, this is the pin is, yeah. So this is not the one that we want. This is the one. So it's 500200. 500200 is the part that I saved. 50020. Yeah, exactly. This is the part that I saved, right? Okay, cool. And yeah, right angle. So this is what I was talking about. Right angle to pause. And another part that we were looking at was under housing sections, which we are looking at this right now. Again, the same thing, two position, uh, one row, and 3 mm pitch. Apply ACAD in stock, apply all. Yep. I believe this is the one that we were looking at. Yep. Yep. This is it. 50200, right? 50200. 50200. Okay, cool. Yeah. So, and the last connector that I would like to show is so we have 1 through 4 parts. And another part, yeah, that I would like to mention is that the crimp, right? So how do I know that how the crimp, where it's gonna go? I mean, okay, so from here to here we know the pitch, we know the dimension, and we can import a mechanical um, step file, and then you can check, right? Now the for female part, since this is a housing, there's no connector. We don't need a crimp. How are we going to choose that crimp part? Right. So for that, you're gonna need to read a data set, like what's the size of this hole right here, and quickly um, yeah, check them. And nonetheless, these are the parts that one of my friends suggested. So yeah, I chose one of them, and on this page I don't remember which one I chose, but yeah, this is the one I believe. Yeah, so this is the one, and it's 20 to 24 AWG, and it's gold coded. Um, Again, so if you go to product index, connector, rectangular connector, context, and you'll find all the specification, and then yeah, you can choose as per requirement. Okay. Um, yeah. So so we have gone through 5 parts, and the last connector that I would like to talk about is um, one of this connector right here. Yeah, so this connector right here. These are very specialized connector for backplane. Um, yeah, this one. So for that, what I'm going to do is go to product, connectors, backplane connector, and specialized. So here what I have is it's like 3 rows, 96 total 96 pins, and 3 by 32 header, right? So that's all I'm going to search for now. So number of position is 96. Number of um, row is 3, and let's apply and check. It already boils down to, yeah. And I'm gonna need ecat in stock. Yeah. So this is the only connector which has its 3D model um, and it's in stock, right? Let's see the 3D model. Yeah. So this is exactly what we want, and it's 90-degree. Yeah. Is it the one that I have? 5533 268 5533 Yes, cool. So this is how you can select parts, and yeah, I think I can add one more for RJ45 connector. This will be under. Okay, let's say for example, I don't know which section it will be under, so I'm just going to type RJ45, then jacks with magnetics. Yeah, so now you can see, right? Connector, modular connector, jack with magnetics. Connector, modular connector, jack with magnetics. Now I can start choosing, okay, USB RJ45 with USB A, number of ports, rows, blah blah blah, and um, yeah. So the most important thing that I generally look for is this one, 10 base T 100 or 1 giga. Um, one, yeah. So I would generally go for the one with an LEDs and with RX LEDs, and at least supports 1 gig. Uh, yeah, and relatively cheap as well. If you want to go for 10 gig and all, it will have different. Um, I don't know whether, yeah, I don't see any above 1 gig. Anyway, yeah. Okay, so if I say 10 gig BST apply. Yep. So these are 10 gig BST, and I just want number of row and number of port one. Uh, for example, here north port is 1 2, so we have two Ethernet, right? So I just want 1 and 1 apply, and oh, we have SMD. It's interesting. Yeah, so we can choose whatever it. Okay, how much it cost. I'm gonna need one in the future. Oh, it's cost $14. Wow, 11, 15, 8. Okay, this is the cheapest. Let's check this. Hmm, okay. Anyway, so that's all for part selection. Uh, yeah, and how Digikey is organizing the part, and you can fully utilize this in your organization to your benefits to quickly search your part that you're looking for. Yeah, that's all for today. Ciao, guys.